Hi, my name is Catherine Won here, and my metric norm is S6158. And today I will present my final year project titled Web-based IBAN text-to-speech system using pre-trained IBAN TTS model. This slide introduces the background of my project. First, text-to-speech or TTS is a technology that converts written text into natural-sounding audio using AI. It is commonly used in areas such as education, entertainment, and assistive technology, for example, audiobooks, learning tools, and systems for people with disabilities. In education, TTS is especially useful because it allows low-cost creations of audio learning materials. It helps learners to improve their listening skills, pronunciations, word stress, and intonations, which are very important for language learning. TTS is also important for low research language. It allows learners to practice languages that do not have many digital tools such as IBAN or Balinese, and this helps preserve this language for the future generations. However, there is a limitation. Most existing TTS systems only support high resource languages such as English, Spanish, and Mandarin. Low resource languages such as IBAN are often not included. Because of this gap, the focus of my project is to develop a web-based IBAN text-to-speech system. The goal is to promote digital inclusion and support the preservation of the IBAN language. This slide shows the main problem of my project. First, IBAN is a low-resource language in language technology. Because of this, most TTS systems do not support IBAN. This creates a digital gap where IBAN speakers are left behind compared to users with other languages. Therefore, there's a need for a dedicated IBAN TTS web system that allows users to turn IBAN text into speech easily. So this slide shows the aim and objective of my project. The aim of this project is to develop a web-based IBAN TTS system that uses a pre-trained IBAN TTS model to produce natural-sounding IBAN speech. To achieve this aim, there are three main objectives. First is to design and build a web-based IBAN TTS system using a pre-trained model. Second is to convert the IBAN text into audio output so the user can listen to the speech. And third is to evaluate the quality of the speech in terms of naturalness, intelligibility, and accuracy. For literature review, I have reviewed the three existing TTS web applications such as TTS Reader, TTS Mapper, and Loop Voice. Clearly show this gap. I have compared this system. This comparison table shows that although this system provides features like text input, voice options, and more, but none of them support IBAN language. This highlights a gap in current TTS technology that my project aims to address. The purpose of the proposed system is to overcome lack of IBAN language support in existing TTS system. Key features include manual text input and alert, Google sign-in and account management, store history of previous conversations, audio playback with speed control, support MP3 audio download, and user feedback for audio quality evaluations. The system is built with Select.js for the front end and Bus API for the back end. Firebase is used for authentications and cloud storage, and the speed is generated using the pre-trained model, Facebook, MMS, TTS, IBM model. The development is done in Visual Studio Code. So this slide is about the UML diagram that I have drawn, such as activity, use case, sequence, class diagram, and ARD to describe how the system operates. For the activity diagram, the workflow begins by checking the user login status. User can then type the text or upload a file, and the system converts the text into the speech using the pre-trained IBANTTS model. The generated audio can be played, downloaded, and the speed can be adjusted. For the authenticated users, the audio is saved to their history and they can give feedback on the audio quality. The use case diagram shows how users interact with the IBANTTS system. Actor includes guests, authenticated user, and admins. Guests can sign in with Google, generate speech, play audio, control playback, and download audio. Authenticated user can do all these actions, plus manage profiles, view history, submit feedback, and log out. Admins can sign in, log out, manage user and profiles, and view feedback statistics. Include relationship shows mandatory actions like Google sign in, while the extend relationship shows optional actions like downloading audio or manage history. The sequence diagram shows the workflow of the IBANTTS system. The user enters text or upload a file, which is sent to the controller, and then the controller requests speech synthesis from the TTS service, and the generated audio is returned. For the authenticated user, the audio is stored in the database, and finally, the audio is sent to the web interface for playback. Next is the class diagram. The class diagram consists four main classes, which are user, conversion history, audio, and feedback. User class manage authentications and account management. Each user can have multiple conversion history records. Each conversion history records links to an audio file, and last, each conversion history record can have none or one feedback. This slide shows the EID. The EID shows the data structure of IBANTTS system. There are four main entities in this EID, which are user, history, audio, and feedback. The EID shows that a user can have multiple history records. Each record links to one audio file entry, and the feedback is optional, which means that each history record may have 0 or 1 feedback. This design has organized user data, generated audio, and feedback efficiently. Now we can see the UI of the IBANTTS web app. So this figure shows the IBANTTS web interface. The login button is placed at the top right corner for the user authentications, and the text input area is placed in the middle for the manual text entry. The file upload icon is provided for the user to upload a file, and the clear text button is also provided to let user to remove the current content. The generator button is used to convert the input text into the audio output. This figure shows the sign in or sign out window with Google login. If the user decides not to sign in, they can click the pause button to return to the home page. This figure shows the home page after signing in. The profile icon has a drop-down menu showing the user name and email. From here, user can access their profile, view history, or sign out. Is the UI of the user profile page. The user profile page displays the personal information that includes profile picture, name, and email. And user can also choose to delete their account from this page. This figure shows the history page. It includes a search bar and a table listing past TTS conversion with text, depth, audio, and feedback. The user can also download or delete the entries from this page. Thus, this figure shows the generated speech interface. The user can play the audio, adjust the playback speed, and download it. For the login user, The feedback icons are also available to read the audio. In conclusions, while current TDS tools offer many features, but they do not support the IBAN language. This project addresses this gap by using the Bitcoin model, which is Facebook MMS TDS IBA model with a modern word step to create a web-based IBAN TDS system. That's all from me. Thank you.